Okay, good morning, my student. So, uh, last chapter we have studied the electrostatic, and we have studied how can we induce electrostatic charges, and what are the difference between positive and negative charges, and what are the behavior of negative charges or positive charges. When positive charges attract a positive charge, what will happen? When a positive charge attracts a negative charge, what will happen? And today we are going to study a new chapter about electricity. Okay, so electricity is the main thing in our life. Okay, so we have using electricity every day in our life. Okay, for many purposes. Okay, like light, uh, but we have to understand today how can we produce electricity and how can we use it. Okay, so the main goal of our lesson today is to understand what is electricity and what is circuit. Okay, and what about current. Okay, so those are three elements that we are going to study today. So you have just to remember that, okay, we have, as I told you from the last chapter, we have positive charges, okay, and we have negative charges, okay. And as I told you, positive charges are located inside the nucleus, and negative charges are located outside the nucleus, okay. And they are attracting each other. So when you have a positive charge and negative charge, they are attracting each other, okay? And when you have the same charge, for example, suppose you have a negative charge, okay? Suppose you have a negative charge, okay? Negative charge and another negative charge, they are going to repel each other, okay? So the behavior of negative charges, they are attracting each other, and positive charges, and they are attracting, repelling each other. But when you have difference in the charges, they are going to attract each other, okay? So, and we have understood what we mean by atom, okay? And that atom has the basic charge, okay? That it has negative charges, electrons, and positive charges, protons, okay? So, and we said that the net charge of the atom is there is no net charge because we have proton and electrons, and both of them are equal in the amount and opposite in charge. So this makes the atom neutrally charged. Okay, so what we are going to study is what we mean by electric circuit. Okay, so you have you have studied before the concept of you have studied before the concept of circuit in math. Okay, so circuit, as you may remember, is uh, something that has no end, no beginning, no end. Okay, it means if I have this circuit here, I'm going to suppose this is a circuit, okay? So you will never find any end or beginning for this circuit, Okay, so this circuit is continuous all in all directions. Okay, if you are going to just open something inside the circuit, okay, so this circuit is not going to be exist. Okay, why? Because the concept of the circuit is depend on you have something that closed, okay, from all directions, and it allow there is no kind of entering point for this system. Okay, so all the direction of this circuit is closed. Okay, there is no space to let anything to move inside the circuit. Okay, so this is the concept of circuit, and as we introduced the concept of circuit in math, we are going to deal with the circuit in electricity in the same way. So what we mean by circuit in electricity is the same. Is it's a closed loop. Okay, means it's a closed path that allow the current. Okay, we are going to talk about current in a few minutes to move through the circuit. Okay, so to talk about electric circuit, you have just to first point you have to keep in your mind that elect electric circuit is closed, okay, from all directions. If you have any kind of opening inside the circuit, this is not considered as a circuit, okay? This is not considered as a circuit because it's a closed path, okay, and is not broken, and it allows current to move in certain direction, okay? So if you have something, okay, that is not closed, okay, mean this is not electric circuit, okay, means the current will come at certain point and the flow of current will end. Why? Because you have opening, you have breaking inside your circuit, okay, and this is against the concept of circuit, okay. So as I told you, circuit is a closed loop, closed path that allows electron or allows current to move through the circuit. Okay. So the second thing we are going to talk about is what are the ingredients of the circuit. Okay. So like we have to understand what we have to call our circuit as a circuit. Okay. So the first thing we have is a source of electricity or light. For example, if you have inside your mobile phone, you have a battery, and batteries is considered as a source of electricity. Okay, and inside like our like the what makes electricity operating in our hmm? Okay, so electricity is a closed loop that allows electron to move uh, through the circuit. Okay, so as I told you, okay, the circuit it has to be closed. Okay, why it has to be closed? Because if you have any kind of loop inside the circuit, the current is not going to move through the circuit. Okay, means the amount of electrons will not move through the circuit. Okay, so this is the concept of circuit. Okay, so what about the ingredients of the circuit? Okay, what we have inside, okay, to call this as a circuit. First, you must have some source of light. Okay, so the first thing you must have inside your circuit some source of light. Okay, so first thing is source of light. Okay, this source of light might be a battery. Okay, means you have a battery that produces electricity for you inside the circuit. Okay, what will be the function of this source of light or battery? it will produce electrons. It will allow electron to move from one position to another. Okay. And the second thing is filament. Okay. Okay, which is uh, through this filament, the electrons or any kind of wire that allows electron to move through. Okay, like because electron can't move like if you have a circuit, if you want to produce electricity inside some room or something like that, you must have some kind of wire that allows electron to transfer from one point to another. Okay, so the third thing is light bulb. Okay, like lamps. Okay, what is the function of this? Is just you are going to identify that you have something. This is the indication of electricity. When you have the light bulb, means you have indication that inside this circuit you have something. Okay, inside this circuit you have light. Okay, and the identity, like the indication of this light, that you have a light bulb and this light bulb is going to produce electricity. Okay, and last thing we have to find inside our circuit. So we have said source of light, battery, light bulb, uh, wires. Okay, and the last thing is a switch. What are the functions of the switch? I told you from the beginning, if you remember, that the circuit must be closed. Okay, so it's not allowed to leave any opening inside the circuit. Okay, and any opening in this is inside your circuit means this circuit is not working well. Okay, means this circuit is not operating in this way. Okay, so switch is something that it's a key that like the like the electricity switch in your home for heater, for fridge, for anything, for even for light, for any device that depends on electricity, you have a switch. Why? This switch, when you are going to close the switch, you are going to produce electricity inside your home. Okay, or inside your device. Okay, when you are going to open the like switch off the device, you are going to open the electricity. So sorry, open the circuit. So when you are opening the circuit, no current is producing, no current is moving through your circuit. Okay, so me switching off your electricity means you are opening your circuit. Okay, means there is no current moving through the circuit. Okay, switching on your circuit, okay, means you are closing the circuit and means you are allowing current or electrons to move through the circuit. Okay, so those are the four important ingredients that we must find inside any circuit. Okay, so I will repeat this again and I will repeat the function of every part of them. Okay, so first you must have source of light. Okay, like batteries. Okay, batteries are working as a source of electricity inside our system. Okay, like the battery in your mobile phone. The battery of your mobile phone is working on operating your phone. Okay, without this kind of battery, your phone is not going to work in any way. Okay, so the second thing is wire or filament or anything like can allow electron to move through. Okay, because if you want to produce electricity inside your system, you must have something that allows electron to move through, and then you will produce electricity by this way. Okay, so the third thing you have to have to produce electricity is light bulb. A light bulb is an indication that you have electricity. Okay, so if you have a light bulb and this light bulb is, is lit. Okay, so this means at this moment that you have electricity. Okay, and the fourth one or the last one is switch. Okay, what is the function of a switch? Is just to open and close your circuit. Okay, when you are opening your circuit, okay, means when you are just you are switching on your circuit, means you are closing your circuit and allowing electron to move through the circuit. Okay, you are switching on your circuit. Okay, switching off your circuit means you are opening the circuit and create the path of the. Okay, So those are the four important ingredients that you have understand about the movement of electricity. Okay. So now to we are going to try to draw from what we have uh, seen now. What will be the source of electricity? What will be? How can we, like how can we draw a certain diagram for the circuit? Okay. So imagine I told you we have four things. So the first thing is source of electricity, and this is a battery, and I will just try to draw the battery in this way, and then we have filament of wire, and this is the wire. Okay, this is the wire, and I have what? I have light bulb, and I can just represent light bulb in this way. This is the light bulb, emit light here. Okay, and lastly I have switch, and this is the switch. Okay, so these are the representation of our circuit. Means here this is the source of electricity. Here is the wire, okay, that allows electron to move through, and this is the light bulb, okay, and this is the switch. Okay, when you are switching off your electricity means you are opening the electricity. Switching on the switch is means you are allowing electricity to move through the circuit. Okay. Okay, you can see here the same that we have uh, drawn, but in a good way. This is like if you are going to think about this diagram here, what we have here. Okay, we have this is our source of light or source of electricity. This is our battery, okay? And you have here, this is the current, okay? And you have some kind of like this is might be a light bulb, okay? And this circuit allows electron to move through, okay? So the circuit is controlling the movement of electron from one side to another, okay? And the bus of electricity is closed. It has to be closed, okay? It can't have some open bus inside the electricity. You are not allowed to just let the bus open unless you are not going to produce any electricity, because the condition that required to produce electricity inside the circuit, it must have you must have some closed path, okay, closed pathway for the electron to move through. Okay. Okay, so we are going now to talk about what we mean by current. Okay, so what we mean by current. Okay, current is, as I told you. Okay, so imagine you have electron moving. Okay, so if you remember the last chapter, we were talking about that electricity that is not moving, okay? And we call this electrostatic, okay? So electrostatic, basically you will just trying to rubbing some kind of pen with anything to produce electricity, okay? Like the electricity induced by the pen and piece of paper. And here we are talking about different kinds of electrons. We are talking about different kinds of charges. We are talking about charges that move from one point to another. Okay, so electrons themselves move from one point to another. Say the circuit to produce electricity. So we are not talking about um, static charges. We are talking about dynamic charges. So the charges themselves are moving from one point to another. Okay. So what we mean by current in this way? So the current, the movement of electron from movement of electrons from one point to another. Okay. So the movement of electron from one point to another is known as the electric current. So the electric current is known as the movement of electrons. So you have electrons that transfer from one point to another, okay? And this kind of transformation of electrons from one point to another is known as electric current, okay? So when you have inside the circuit, okay, electrons that can move from one point to another, okay, we call this electric current, okay? So now, what we mean by this, how many electrons is going to move through this circuit, okay? Maybe millions, maybe, because electrons are very, very small, okay? So you have, like you have gigantic number of electrons moving or passing through the circuit every time, okay? So the rate of a change, okay, of those kind of charges with the time is known as the current, okay? So the rate of a change of what? Of charges moving through certain point at certain time is known as a current. So you have, first of all, you have circuit. This circuit, you have inside the circuit, you have electrons move from one point to another. So the rate of moving, the rate of change of this electron from one point to another is known as the current, okay? So the current is the change, the movement of electrons from one point to another, okay? So how can we measure the electric current? We can measure electric current by unit of ampere, okay? Unit of ampere. This Ampere was a scientist who worked in this area, and we have dedicated this unit for him, okay? Thanks to his effort to introduce the concept of electricity to us. So we call this ampere or A, okay? So what we mean by A, the rate of a change of charges of electrons moving through certain time, okay? So the rate of a change, okay, means dq by dt. What we mean by that? We mean that the rate of a change means the difference in charges. Okay, for example, you have 10 electrons moving in 1 minute and another 100 electron moving after a few minutes, okay, a few seconds, okay? So the rate of a change of this charges over time, okay, this is known as the ampere, okay? And as I told you, we are talking about uh, dynamic charges. Those charges are changing with time, means these charges are moving from one point to another through certain time, okay? Mariam,
Good morning.
good morning.
I have a question.
Yes, ask.
What's the difference between electricity and static electricity?
Very good question. Thank you. Okay, so the static electricity, as I told you from Mariam, that in static electricity you have charges that can't move. Okay, they are stationary in their place. Okay, they can't move from one point to another. Okay, but when we are talking about normal electricity, the kind, like the way you can generate electricity, like normal electricity inside your circuit, can be done by moving electrons from one point to another. Okay, so you are not allowed to create electricity or generate electricity inside your circuit without let the electrons to move from one point to another. Okay, but static electricity, you are going to generate electricity by yourself. For example, remember the example that we were talking about last time, that by like by just trying to inducing the like charges inside the bin, okay, by rubbing the bin with something that have electricity, okay? And by this we can, you are going to produce electricity between the pen and the piece of paper. And we were talking about this as a source of electricity, okay? So this is a source of electricity, but this kind of electricity, we call it electrostatic. Why? Because the electrons, the charges themselves are not going to move. They are not going to transfer from one point to another, okay? So only the charges will be stationary, doesn't move from their place, okay? And actually by just trying to induce them, we are going to produce electricity. But when we are talking about electricity in circuit, electrons are going to move from one point to another. And this is the difference between this kind of electricity and the electrostatic. Rawan?
Mr. What about the electrical signals in our body? Can our body be like a circuit?
Yes, yes, our body, very good. Okay, so our body can create electricity in the same way. Like imagine, like our bodies actually is. For this reason, when you are touching something, okay, you can feel a little bit electricity inside your body because actually our body contain electricity. Okay, and we are going for just to be isolated, we are going to use something that can't conduct electricity. For example, like plastics can't like doesn't conduct electricity. So our body contain electricity, and our body might be charged, okay, into positive charge and negative charge too, okay. But the amount of a charge, like our body is like we have charges inside our body, okay, but the amount of the charges in our body is not going to produce the same kind of electricity that we can see during the through the battery, okay. So yes, our body is a charge, okay, and it can like conduct electricity in some way when it's really connected to source of electricity. But our body is not a source of electricity. We don't have some circuit loop inside our body that tell us this is a direction of electricity inside our body. Okay, so yeah, we have a source of electricity, but this source of electricity can appear when you are attracted to, or we have a charges inside our body. But this can be appeared only if you are going to be connected with the source of electricity. Otherwise, you are not going to produce electricity inside your body, okay? So this is not a circuit, like we are talking about circuit, how circuit is transferring electron from one point to another, how electrons is moving through the circuit. But when you are talking about this, the loop inside your body, no, yeah, we have some kind of positive charges, negative charges, and this can produce electricity. But when you are connected through the loop, for example, suppose your body is connected to source of electricity, your body will feel electricity moving through this, moving through body, but you are not allowed to like to produce electricity by yourself. Okay, this is the difference. Okay, if you don't have any questions, I'm going to show some demonstration about this electric circuit for you. So if you don't have any questions, I'm going to show this now.
Let's begin by looking at how a simple circuit allows a light bulb to light. A circuit is a route through which electrical current can flow. In our example, electrons flow from the negative side of a D-cell battery to a conducting material on the base of the bulb. From there, the electrons flow up a wire that is inside the bulb and across the filament, which is the part of the bulb that actually lights. When the electrons go through the filament, some of the electrical energy is changed to heat and light energy. The electrons continue down another small wire inside the bulb to another conductor on the base of the bulb. The electrons finally make their way to the positive side of the battery. There would not be a complete circuit if the electrons did not travel to the positive side of the battery, and the bulb would not light. When there is an unbroken path on which electrons flow, as in this example, it is called a complete circuit. The unbroken path that the electrons follow is called a closed circuit, because electricity will only flow on an unbroken path. The light bulb will not light unless there is a closed circuit. Now look closely at the light bulb, and you'll notice that there is an insulator between the conductor that leads up to the filament and the conductor that leads away from the filament. Remember that the atoms of conductors easily accept and pass on electrons. The atoms of insulators do not. As we discussed in the first section of the lesson, electrons will not easily pass through insulating material that surrounds a wire. If an insulator did not surround a wire carrying a current, it is possible for the electron flow to get directed to another conductor that comes into contact with the circuit. Electricity will follow the path of least resistance. If the electrons take a path short of the complete circuit, it is called a short circuit.
Okay. Okay, do you have any questions before we end this meeting? Okay, thank you for, you are going to receive a worksheet related to this part, and I hope you are going to solve this sheet. And if you have any questions about this, okay, just send me a message, okay, and I'm going to respond to your message, okay? Okay, thank you. See you next week.